Hello and welcome to another geometry lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 1, Lesson 2 on circles and arcs. Now remember, we're trying to build geometry from this sort of base foundational level. So everything that we do at the beginning, even though you've probably seen much of it, is very, very important to understand. So let's get right into it and start thinking about circles and arcs. Now let's first define what a circle is. Now that we've defined the ideas of a point and the distance between 2 points, we can introduce one of the most important ideas in geometry, that of a circle. So let's get right into it in exercise 1 and take a look. Given point C shown below, do the following using a ruler and compass. Letter A, locate any 5 points that are 4 centimeters from point C. All right, so this is simple enough, right? I take my ruler out. I put the 0 down at point C, I go out to 4 centimeters, and I put a little dot. Now, you might want to put yours a little bit closer to the ruler, but if I get too close to my ruler, what's going to happen is it's going to try to draw a line segment instead of a point. So there's a point that's about 4 centimeters away from point C. Now, I want to locate 5 points that are 4 centimeters away from C. All right, so maybe I could just sort of rotate my ruler up a little bit here. I want to make sure that I keep my 0 at point C. And here's another point that is 4 centimeters away from point C. All right, what I'd like you to do is pause the video now and just locate, a few other points. I guess in total, I'd like you to locate 5 points that are 4 centimeters away from point C. So go ahead and do that. All right, well, there are many choices. Maybe I'll put one over here. Again, got to get that a little closer, but maybe I'll have a little, there's my ruler going there. Make that a little bit darker. Maybe put a point right here. Now I'll throw one down here in a little bit, but I'll do a point there. Maybe I'll put a point right around there. All right. Not the greatest, but they'll do the job. All right, so I've got a bunch of points that are 4 centimeters from C. In fact, there are an infinite number of points, right? Because I can put one up here and one over here and one down here. There are lots and lots of points that are 4 centimeters away from point C, right? In fact, let's take a look at that in letter B. How many points, marked or not, lie 4 centimeters from C? All right, well, why don't you go ahead and write down what you think the answer to this question is. All right, well, it's an infinite number of points. All right. In other words, I could keep plotting point after point after point after point. Now remember, points have no physical space. They take up no physical space. They are simply a location. So what I am saying is that there's an infinite number of locations that are 4 centimeters away from point C. Now, letter C, how can we draw the set of all points that are 4 centimeters from C? Because drawing them one at a time is going to take far too long. So think about this for a moment. All right, well, what we're going to do is we're going to draw a circle. Whose center is at C and whose radius, that doesn't look like the word radius, whose radius is 4 centimeters. All right, so let's do that in part D. Let's do it together. Now, a little bit tricky because we have to set how long our radius is, although we do know that all of these points are 4 centimeters away from C. So all I have to really do is open up my compass, right? A compass is what we're going to use to draw circles. A Yeah, a compass is what we're going to use to draw circles. So what I do is I put the pointy part of my compass at my center point. I extend it out so that this length is 4 centimeters. And then I simply rotate it all the way around. And if I've done a good job in plotting those original 5 points, then my circle will go through each one of them. And it does. 1, 2, 3, 4, 5, or at least comes close, right? And that's the idea of a circle. And this is so critical to understand. Let's take a look. A circle is the set of all points that lie the same distance, we call that equidistant, from a given point, called the center of the circle. Circles are oftentimes named using their center point. All right, so this is critical. All right, and I want to pause just for a moment here because a circle is such a simple shape. It's something that you literally saw probably when you were like between 1 year old and 2 years old in like a picture book. And your parents were probably like, that's a circle, that's a square, that's a triangle, etc., etc. So you've been seeing circles for a long time, but in math, they have a very strict definition, right? They are the set of all points that lie some distance, whatever that distance is in our problem that we've been working on, that was 4 centimeters, some distance away from a given point. Now the given point is not part of the circle, right? It's just the circle's center, right? It's where we're measuring that distance from, okay? Very critical. All right, let's take a look at exercise number 2. Given points E and F shown below, do the following using a compass and the ruler shown. Letter A, draw all points that are 3 centimeters away from E. All right, so again, in theory, we could take out a ruler and go, oh, that's 3 centimeters away, that's 3 centimeters away, that's 3 centimeters away, but it would take forever, right? So what we do is we take our compass out. All right, again, should be a little bit easier for you. I'm gonna put my pointy end down at the 0. I'm gonna stretch this out to a length of 3 centimeters. Then I'm gonna bring my compass over. I'm gonna put the pointy end on E. And then I'm gonna throw my distance off. Well, let's try that again. All right, we're a little rusty with the compass. We're gonna get there. All right, and there are all the points that are 3 centimeters away from point E. All right, any given point on this circle, if I then took that ruler and I measured it from point E to the point on the circle, it would be 3 centimeters. Let's take a look at letter B. Draw all points that are 5 centimeters away from F. Well, why don't you go ahead and do that? All right, let's do it. 5 centimeters away from F. Let's see if I can get it right this time. All right, give my sharp pointy end there. Okay, let me just make sure that looks like 5. Pretty good. Put the pointy end here now, and let's do it. Okay. And let's just move this out of the way so we can see clearly. All right, larger circle, right? Because now we're talking about points that are farther away from F than they were from E. Now there's a little bit more to this problem. Letter C. How many points are common to both circles? What do these points represent in terms of distances? So how many points are common to both circles? In other words, they're shared by both circles. Take a look at the diagram and see if you can answer that question, and then follow it up by seeing if you can answer the second question, which is, what do those points represent? Well, of course, we're talking about intersection points again, right? So specifically, this point right here, that's common to both circles, and this point right here, that's common to both circles. So the first question, how many points are common to both circles? Well, that answer is just 2. Okay, but what does that represent? And this is very important, right? These 2 points are 3 centimeters away from E. And they're also 5 centimeters away from F. So they are the only 2 points in this diagram that are 3 centimeters away from E and 5 centimeters away from F, right? So they are the only points that are both, and that's critical, 3 centimeters from, I think it's E, right? From E, and 5 centimeters from F. That's critical because we are going to be using compasses and circles to locate points in the plane, specifically points that we might know are a certain distance from one point and at the same time a certain distance from another point, okay? And we will find those points by looking at intersections of 2 circles. All right, let's keep going. Now, some circle terminology, and this is stuff you've seen before, but let's take a look at it again. A radius of a circle is any line segment drawn from the center of the circle to any point on the circle. In other words, right, if I've got this circle, right, and I've got point C, right, and point A, so the center of the circle and a point on the circle, and I draw that line segment in, then that is what's known as a radius of a circle. Now, because circles have an infinite number of points, there are also an infinite number of radii, but they are all the same length. So sometimes when we talk about the radius of a circle, right, in formulas like pi r squared or pi times, 2 pi times the radius or whatever, right, we're actually referring to the length of the radius. All right, let's talk about this second piece. A diameter of a circle is any line segment drawn from one point on a circle to another point on a circle that passes through its center. Okay, that's key. And again, I want you to keep in mind, when I refer to points on a circle, I'm talking about points on this curve. I'm not talking about points that are on the inside of the circle or on the outside of the circle. I'm talking about points that lie along here. So a diameter, again, is a line segment that goes from one point on a circle to another point on the circle, but passes through its center. And so it looks something like that. So if I've got point A lies on the circle, point B lies on the circle, and I draw that segment in and it happens to pass through the center, then AB is a diameter of circle C. Simple enough, right? Okay, now let's talk about, hold on. Sorry, I knew there was a problem I was missing. I'm going to skip an entire problem. You'd be like, why did he skip problem 3? All right, let's take a look at exercise number 3. In circle M shown below, points A, B, C, D, and E lie on the circle. Point F is at the intersection of A, C, and B, D. Points B, D, and M are collinear. Remember from last lesson, that means they fall in a straight line. Letter A, list all radii shown in the diagram, use segment notation. All right, great. So I'd like you to write down the names of every single radius that shows up in this particular diagram. Pause the video now. All right, a radius is a segment drawn between a point on the circle and the center of the circle. So the easiest thing to do is look at the center of the circle and look at any line segment that goes from that point to a point on the circle. So for instance, one radius on the circle is radius EM, right? That's this guy right here, okay? Another radius of the circle is radius BM, and then another radius on the circle is radius DM, all right? You can absolutely write those as radius ME, radius MB, and radius MD. Those are all fine. Remember, we can name segments using either starting point or ending point. All right, let's take a look at letter B. List all diameters shown on the diagram. Use segment notation. All right, now diameter, of course, is a line segment that starts and ends on the circle, but also passes through the circle's center. Pause the video now and write down the names of any diameters that are shown in this diagram. All right, well, there's only one. Now, there are two segments that begin and end on the circle. There's segment AC, that begins and ends on the circle, and then there's segment BD, that begins and ends on the circle. But only one of those two segments goes through the center, and that segment BD, right? So there's only one diameter on this, and it's segment BD. All right, finally, and this is probably pretty obvious, but let's talk about it anyway. Letter C. Explain why the length of the diameter of any circle must be twice the length of any radii of the same circle. All right, well, let's see if you can explain that. Pause the video now. All right, well, the plain fact is, let's just take a look at the one diameter in this particular diagram, right? The one diameter in this particular diagram is this segment, right? And we already know from the last lesson that if we took the length of BM and we added to it the length of MD, we would get the length of BD, right? And that's because these things are collinear, right? So if I took the length from B to M, the length from M to D, we would get the length from B to D because those 3 points are collinear. But both of these two things are radii, right? That's a radius, and that's a diameter. So it really gets at the essential heart of things, which is that every diameter is the sum of two radii. Every diameter, right? One radius going from one point to the center, and the other radius going from the center then to the second point. All right, very important. All diameters are twice the length of radii. Now let's talk about arcs of circles, or just arcs. An arc of a circle is a connected set of points on a circle that lie between two particular points on the circle. Arcs are very similar to line segments that are bent around a circle. So in other words, right, we've got some circle. Okay, and let's just say we had 2 points on the circle, point A, point B, right? We could then talk about all the points that lie in between A and B. So this arc. Now, you might say to yourself, well, wait a second. They're the points that lie between A and B in this direction, and then there's the points that lie between A and B in that direction. And that's where arcs and segments are very different, right? On a segment, right, you're just locating 2 points along a line and you're going, okay, we're talking about these points in between, right? On a circle, well, you got these points in between A and B, and you have these points in between A and B. And when we get to unit number 9, which is on circle geometry, and it is a long ways away, but when we get there, we'll talk about what are called minor arcs and major arcs of a circle. But right now, you just want to understand that an arc is any section of a circle that's got sort of 2 endpoints on the circle. All right, so very, very similar to a segment and a line, except in this case, we have a circle and an arc. Let's take a look at exercise number 4. In the diagram below, points L and M are equidistant from point C, meaning that if we measured CL and CM, they would be the same length. Letter A, draw an arc from L to M that is less than half a full circle. Label the arc LM. All right, this is simple enough. So what I'm going to do, right, because I know that they're equidistant, I can put the tip of my compass on point C. Again, going to be a little bit easier for you. I then want to extend the compass so that it's got a radius. That's right, we talk about the radius of the compass, right, equal to the length of either CM or CL. And then I'm simply going to draw that arc. I missed, but that's okay. That's about as good as I'm going to get. Hopefully you've got one that's a little bit better. All right, and that is what we call arc LM. And here we go again, right? How many things are we going to name that's got 2 capital letters and then some funny thing over it, right? So far we've got, like, if there's a line symbol above it, it's a line. If there's a segment symbol above it, it's a segment. And now if it's an arc symbol above it, it's an arc, okay? So here we have, and it's less than half a full circle, right? More than half a full circle, we would have been going in this direction. Okay, so easy enough to draw arc LM. Let's take a look at letter B. Place a point anywhere on the line between L and M. anywhere on the arc between L and M. Okay, so go for it. Go ahead and put a point anywhere you want on that arc, nice and filled in, and label it point P. Pause the video just for a moment to do that. All right, simple enough, right? If I just kind of went in here and I put P in there, great. All right, so somewhere, anywhere on here, I want you to have P in there. Okay, now let's take a look at letter C. Explain why the distance from C to P must be the same as the distance from C to L and C to M. Great. All right, so why must that distance, and that distance all be the same? Pause the video now and see if you can write something down. All right, well, it's really simple. And again, it's very important, right? An arc is part of a circle. And all points on a circle, and therefore on an arc, are equidistant from the center point. Okay? So all points on an arc are the same distance from the center point. Because that's a U, because arcs are portions of circles. All right, so very important. Many times we will be drawing full circles, but many other times we'll just be drawing arcs, all right? And the key is, right, every point on an arc is the same distance away as every other point on the arc from that center point, every single one of them. So if I took a ruler out and I measured that length, that length, that length, or the length from this point to any point on this arc, it would be the same. Very critical. All right, so let's do a little summary, right? Today, we talked about circles and arcs. And again, this idea, this circle, being the collection of all points that are a certain distance away from a center point is so absolutely critical in geometry. In the original book on geometry, which was called Euclid's Elements, circles are one of the first things that he discussed because they are so critical in the foundations of geometry. We're going to see them in tons of lessons going forward, so you'll get used to them a lot more. For now, I just want to thank you for joining me for another geometry lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.